Welcome to the FlowGraph tech demo for modeling a dual bus electrical system. In the next few minutes, you'll learn how to create a dual bus electrical network using FlowGraph and its liblec exporter. The network we'll be modeling is based on a diagram from the Aircraft Systems Tech website. Our reference diagram shows the AC bus at the bottom and the DC bus at the top. In FlowGraph, we'll model from left to right, so our network will be rotated 90 degrees to the right. Let's start by modeling the generators and dual AC bus. For simplicity, I'll model the external power source as an AC generator in FlowGraph. If we have a look at our diagram here, we have our AC side of the bus on the bottom, we have our DC side of the bus on the top. In the middle here we have some inverters and some TRU units. We're going to jump over into our canvas and start modeling this up. I'm going to drag this image onto my second screen so I can use it as a reference. I'll come into here, into FlowGraph, right click, liblec, generator, another generator, another generator, one more, and this will be our emergency generator. We will click our node, we will give it some names that match what we see on our diagram. That makes it easier to reference. It's also required for the liblec export file. This is going to be external power. This is going to be the APU. This one here is Gen 1. Now I need to put some ties in place. As I drag, you'll notice that my pop-up menu is filtered to only give me nodes that are useful. It's not perfect, but it's pretty good for now. Come back up the top, we're going to drag this one over into a bus node. I'm going to have a bus node in the middle here between these. We have a tie in here. So I'll drag this back over here. And we're going to repeat this structure in a second, but for now I'll just pull the diagram in so you can see it. So we have a generator into a tie, into a bus. We have a APU into a tie, into the central bus, and then the central bus has a tie before it goes into AC bus 1. So generator, tie, bus, that's those three. APU, tie, bus, tie. APU, tie, bus, tie. AC bus 1. Jump in here again. Give this a name. APU XT bar. This is BTB, I think it was. Let's have a look. Yes, BTB 1 and 2. So I've got BTB 1. Now, the bottom half of this bus down here is a mirror, so I need a bus node, and then a tie node, and then that one. This is going to be AC bus 2. This is going to be BTB2. So we'll neaten this up because it's going to get pretty wide by the end. Okay. We now have up to about here in the network modeled. We need 2 more ties and an essential AC bus in the middle. So we'll come in here, we'll have a tie, we'll have another tie, we'll have an essential bus here. So this is AC essential, which is here, comes out into two more ties. Like so. One of which goes to the emergency bus over here, which is going to be this one. I need to come out of here into a bus. So come emergency tie into a bus, which connects over into essentials over here from this one. We'll come out of this and into another tie. No, it's a TRU. Delete, drop a TRU in instead. It's called ESTR. And DC essential bus. That one. DCS bus. This one here is going to come up and give us a TRU. This one here is going to come up, give us a TRU. TR1. TR2. Both of those go into their own DC bus nodes. DC bus 1 and DC bus 2. There's a central battery bus with ties in between. This is DC bat bus. So we've got this, we've got this, we've got this. We need 2 hot buses and some batteries and some inverters. Let's have inverters. That one. And that one. This gets a little bit awkward at the moment because we have to do a reverse link here, which is not great. Actually, I don't want that. I'm going to have another bus node here. I'm going to call this ACINV bus so that we can do this. So now we have a bus node, we need to tie these this way. Now I'm going to fix this up maybe so that we can have node connections from either side when working with liblelec networks. It doesn't really fit in with the rest of how a node graph editor is meant to work and analyze all the links. So for modeling electrical networks, it's a little bit janky and reversed. We need to bring our battery bus into the inverter. No, battery bus does not connect to the inverters. Okay. So now we're going to have 2 batteries. Batteries are going to come out into their hot bus nodes. It's going to be hot bus 2. This is battery 2. And we've got hot bus 1. Scooch these over a bit. And down. Hot bus comes through a tie into battery bus. And this one's going to come into a tie into the battery bus as well. That gives us that, and we've got that. Now we need a hot bus into DC inverter bus. That was hot bus 1. Okay. We'll come up here, we'll drop a bus node. I call this DC INV bus. I'm going to go bang and bang. We need a tie on that though. So I'll drop a DC tie in here. And I'll go like this and like this. And then I'll take this one out. I'm going to try and tidy this up a little bit because it's a little bit messy right now. Let's pull these out like this. That'll do. We got that, we got that, we got that. We got a connection in from DC bus 2 through a tie. We need the essential bus connections. We come down here. We're going to have an essential bus into a tie into a DC battery bus. We go straight into a tie. And then we're going to come over into the DC battery bus. And I'm going to move these just to here to make it a little bit cleaner. This one I want to come out the same. I'm going to come over to a tie into hot bus 2. So I'll come over here. And we'll hot bus into there. And I'm pretty sure that's us done. We got that one, we got that one, we got that one, we got that one. Yep, that's us done. 49 links, 43 nodes. We can now go file, export, libelec, and it'll generate a network file for us.